So for this question, when we consider the forces, the weight is acting downward. When it is, look, when it is at rest, when it was not moving, the weight is acting downward. The force of the Newton meter, that is example R is there. The force of a Newton meter example we called R. And there will be an upthrust. U will be there. When it is stationary, in that case, the R plus the upthrust will be equals to W. That is in the case when it was stationary. But in the question, we are slowly raising it vertically. So we are starting to move this. So when object is moving through the fluid, the fluid will also have a force, and we call that as a drag force, like opposing the motion. So there will be R, there will be W weight, there will be a drag force which is opposite to the motion, and there is an up thrust. But all the cases, because it is moving at a constant velocity, so resultant should be zero. So when it was at rest, this should be the equation. But when it start to move and it is completely underwater, it does not come out. When it is start to move and completely underwater, in that case, we have R plus the upthrust is equals to weight plus the drag. Or we can say R plus the upthrust minus the weight minus the drag will be equals to 0. When object, now we have the sum should be 0. All the cases, because it is moving at a constant speed or a constant velocity, so the sum should be 0 of all the forces. Resultant force should be 0. Because object is moving slowly, when it is raised slowly, the drag force, the force which is opposing the motion, it depends on the surface area, and it also depends on the speed at which object is moving. The surface area is not changing for this object. The surface area does not change. In the question they mentioned it is slowly raised. When slowly raised means speed is very small or drag is very small. So if the drag is very small, drag can be neglected. So we can neglect the drag, or I can put in the expression, that is fine. I can also neglect the drag. So I can also say that because it is moving at a slow speed, so drag is negligible or very small, it can be ignored. So it means the upward force of the Newton meter plus the upthrust will be equals to weight minus weight is equals to 0. Now when it is completely submerged, the weight is not changing. When it is completely submerged, upthrust is not changing. So what should happen to the value of the R? The value of the R should not change, because what is the value of the R here? The value of the R is weight minus upthrust. According to this equation, when we ignore the drag, why we ignore the drag? Because it is moving very slowly raised. That is the indication that the drag is negligible. When object move very slow, the drag can be ignored. So it means R is W minus upthrust. The weight is not changing. When object is completely submerged, the upthrust will not change. So will the R change? So if weight is not changing, upthrust is not changing, what will happen to the value of the R? In the beginning, the value of the R does not change. So if we have a graph for movement, so in the beginning, the value of the R should not change. Then the second point, when it is coming out, when the object is coming out from the water, means some part is inside the water and some part is outside the water. So in that case, what will happen? We have R, the weight is there, and the upthrust. And we know R is weight minus the upthrust. The weight is not changing, it's a constant thing, but upthrust will change. How the upthrust will change? Because upthrust depends on the density of the liquid, the volume of object which is submerged or inside, into gravity. So because when the object is coming out from the water, the amount of as the volume of the water displaced will change. Because when it is completely submerged, it will have greater upthrust. But when it is coming out, a small proportion of the object is underwater. So as a result, the upthrust will decrease. So if the upthrust will decrease, if the value of the upthrust decreases, what will happen to the R? Because R is weight minus upthrust. Weight is not changing, upthrust is decreasing. So what happened to value of the R? So R should increase. That's right. So the value of the R will increase. So means, and what kind of change it will have, you can see the equation is having a power 1, like all have a power 1. So it means it's a linear equation. So what should be the change here? What should be the change here? It should be a linear change, a straight line. Once all of the object is, once all of the object is outside the water, so what is a, now what is, and it is also moving at a constant speed. So I will say R will be equals to W. Upthrust will be 0 or R will be equals to W. So once again, R will be equals to W. So what is value for R? What will happen to value of R? Again, the R will become constant. Is it clear? The variation of the force of the Newton meter or a spring balance when you pull the object which is initially underwater and it move, as it move, the upthrust start to change when the object is coming out. So the value of the Newton meter will also change. So when we check the options, which one it match with, because this is a, like here L is means when object is coming out. This is L, like how much distance L is moved. So when we check option A, why it is wrong? A is wrong because when object is not coming out, when object is completely submerged, like it is inside, the R will not change. So A and B are wrong. Either C can be an answer or D. So first part is this. First, so C or D, both first part is correct. When object is coming out from the, when object is coming out, the length of object is L. So when object is coming out from the liquid and going into the air, then the value of R will change. R is weight minus the upthrust. So the upthrust will decrease. So the value of R will increase. And the change in the R will be a linear change. Why linear change? Because it is the equation with a power of 1. All have power 1. Like this is weight 1, 1 and 1. So it's a linear change. If it was like example, if any equation was there and the relation between R and U was a product, means that is the power 2. Then it will be a non-linear change or a curve. The graph will be a curve. But this is a subtraction of a x, W power 1 and U power 1. So it means it will be a linear change. So we'll have a straight line. And then once all of this object is in the air, so R which is acting up and the weight which is acting down, so R is equals to W. So the force of a Newton meter or a spring balance is equals to weight. So again, it will become horizontal. Like it won't change. So at this point, R is equals to W. At this point, R is equals to W minus U, but the U is decreasing, so R is increasing. And at this point, R is also W minus U, but both of them are not changing, so R does not change. Here, weight does not change, so R does not change. Is it clear, this graph? Question 15, 16, any doubt? Question 15. In question 15, a ball is thrown vertically upward in air. So it means you don't have to ignore a air resistance. Air is having a part here. As it rises, its path before the beginning, beginning to fall vertically downward, it's shown. Assume that the gravitational potential energy is 0 at the start, like at this point, GP is 0. Let's take like kinetic energy is there, say 100 joules of kinetic energy. But because it is air is present in this, the question, so it will lose some energy to the surrounding. So at the center, at the midpoint, what if there was no air? Like because the same question will be with or without air if there was no air present. So if it was having a 0 joules of the potential, gravitational potential, If the gravitational potential energy was 0 here and the kinetic energy was 100, at the midpoint, the kinetic energy will be 50 and the GPE will be 50. But at the top, the GP will be 100, the gravitational potential energy will be 100, and the kinetic energy will be 0 without air. But in the question, there is air present, so definitely it will lose some energy because of the air resistance. So when at the midpoint, the kinetic energy will not be equals to gravitational potential energy, as it will lose some of the energy to the surrounding. So at this point, when it half or midway, maybe the kinetic energy might be 50, or sorry, gravitational potential energy, the GPE might be 50. But because some of the energy is lost because of the work done against the air resistance of work done, maybe 20 joules of energy is lost. So what will be the kinetic energy? The kinetic energy will be 30 joules. So because of air resistance, it will lose some energy. So at the midpoint, the kinetic and the gravitational potential energy won't be same. So which statement about the ball is not correct? As it rises, the kinetic energy is transferred to gravitational potential energy. So as you can see, this is a true statement. Yes, the kinetic energy changes to gravitational. At the midpoint of its path, the gravitational potential energy is equal to kinetic energy. No. Why no? Because some of the energy lost to the surrounding. So the GPE will be not equal to KE. The sum of the KE, the KE, the kinetic energy will be equals to gravitational potential energy plus work done against the friction. The sum will be, the total energy will be conserved, but not the kinetic, not equal to potential. Like the statement here, it will be kinetic energy. The statement here, kinetic energy is equals to potential energy plus work done against the friction. So the sum of potential plus work done will be equals to original kinetic energy or initial kinetic energy. But KE and PE will not be same at the midpoint. Or even at any point, it will not be same. At the top of its part, the kinetic energy is 0. Yes, definitely it will stop. At the top of its part, the total energy is less than the initial. So at the top of its part, the total energy is less than the initial energy. So when because it is losing some energy, so if the initial energy was 100, the gravitational potential energy will not be 100, it will be less than 100. So the total energy will be less than the total energy at the top will be equals to, it will not be equals to the energy at the beginning. So that is why D is also a right statement. Is it clear? Question 15. Question 16, any doubt? 17, 18, 19, 18 and 19. Okay. A car is traveling a half speed, car X is traveling a half speed as Y, and car X has a twice mass as Y. Which statement is correct? So you can say this is car X. We know the formula for KE, the kinetic energy, that is 1 by 2 mv square. So this will be 1 by 2. The car X has a mass half, like the mass is twice, so it will be 2m. The mass is twice, but the speed is half, so speed is v by 2. So when I simplify, it will be half 2m v square by 4. So when you simplify, it will be mv square by 4. That is the kinetic energy of X. What about the kinetic energy of Y? So it is half. Its mass is m because X has a twice mass, so this is m. But the speed is v because the car X is traveling half speed of Y. So speed of Y is v, speed of X was v by 2. And the mass is twice. So if the mass of Y was m, the mass of X was 2m. So half mv square So this will become mv square by 2. So what is the ratio between these two, or how they are related to each other? This is mv square by 4 and this is mv square by 2. I mean, this is 1 by 4 and this is 1 by 2. What is the ratio between 1 by, so I can also say, because if 1 by 2 is divided by 2, I will get this. If 1 by 4 is multiplied by this, so I will get this. So we will check the statements, which statements are correct or the right statement. So car X has a half kinetic energy as Y. That is true, because if the kinetic energy of this one is 1 by 2, the kinetic energy of X is 1 by 4. So how much is the kinetic energy? It means it has a half kinetic energy. So statement A is correct. Is it clear? The relation between X and Y, the kinetic energies. Question 19. The total weight of a motorbike and a rider is 1800 newtons. The motorbike travel in a straight line at a constant speed, which is at an angle of 30 to the horizontal. The useful power of the motorbike is 36,000 watts. The total resistive force due to the air resistance and the friction is 2,400 newtons. What is the speed of the motorbike? So how we can relate? We can relate the power, because we have the power, we have the force, and we need speed. So the formula which relate, that is power is force into speed. Now, the force of the engine, because this F is a force of the engine, how much force engine is applying to maintain this constant speed? Yeah, it is a constant speed, definitely no resultant force. But remember, when we use a formula, power is force into velocity. This force is not the resultant force. This is a force which we need to maintain a constant speed. So this is not the resultant force. This is actually the force of the engine to maintain that specific speed. So they mentioned there's a resistive force of 2,400 Newton. And the weight is acting downward, because the weight is also there, 1800 Newton. So weight is also acting downward. This weight will have the two components. Always remember, on inclined surface, one of the component which is with an angle. So this will be equals to 1800 cosine 30. The component of the weight which is with an angle, 1800 cosine 30. And the component of the weight which is opposite to the angle, that will be equals to 1800 sine 30. So means 1800 sine 30, which is backward, and 2400, which is also backward. To maintain a constant speed, how much force it has to apply? F, example F. So we can say the F will be equals to 2400 plus 1800 sine 30. Is it clear? Because F is a forward force, 2400 and 1800 sine 30 are the backward forces. So these two forces are opposing the motion, and that is balanced with a constant, with a force of the engine F. So 2400 plus 18 sine 30, that we'll get the value for F. The power is already given to us. This is 36,000. So the power is also given. So we just divide power divided by the force which we need to maintain a constant speed. We'll get this constant speed of the motorbike. Is this clear? Question 20, any doubt? 20, 21. Question 20 and 21, okay. Just a simple rule, try to memorize this rule. when springs are connected in parallel. Okay. It's like you used to memorize in electricity, the topic when resistors are connected in parallel. Same way, just remember when springs are connected in parallel, what is the combined spring constant? Like remember when resistors were connected in parallel and resistors connected in series, when they're connected in series, you add the to get the total. When they're connected in parallel, you take a reciprocal and then add them. So opposite will happen when the springs are connected in parallel and I need the combined spring constant. What I will do, I will simply add. If I need the total spring constant, I will simply add the spring constant of the springs. And if they're connected in series, this is just to remember so that you can easily solve this type of a question. When springs are connected in series, if I need the combined spring constant of this system, it will be 1 over R K1 plus 1 over K2 plus 1 over K3 and so on, and then take a reciprocal. Try to remember this concept. When they are parallel, just add to get this combined spring constant. And when they're connected in series, just take a reciprocal of the 1 over reciprocal of the total will be equals to 1 of the reciprocal of the sum and then take inward. Now, P and Q, they mentioned spring P and Q are identical. They have a spring constant K. How they are connected? Parallel or series? How these two springs are connected? Parallel or series? So they're connected parallel. So if they're connected parallel, how to get the total combine of these two? So I will just add the spring constant. So K plus K. So the combine will be 2K. So when they're connected in parallel, we simply add. So means now P and Q will be replaced by one spring. The combine of the PQ is replaced by one spring, which will have a spring constant of 2K. Is it clear? So as they were connected in parallel means they can be replaced by 2K, like the combine. Now, the combine of these two P and Q and another spring R is there, they're connected in series. So if I need the total spring constant of this system, I will add the reciprocal. So 1 over 2K plus 1 over 3K. So if I take an LCM, so 6K will be an LCM. This will be 3 plus 2. So 1 over KT. So KT here I refers to total. So it will be 5 over 6K. If I need the combine, like the total, so it will be 6K over 5. So what is the combined, like example, if these two springs are replaced by one spring, if these two springs are replaced by one spring, so what is the spring constant of that one spring? It will be 6K divided by 5. Now, we need the increase, extension. How it turned into 6K? First, we take an LCM. 1 over total is equals to 1 over 2K plus 1 over 3K. So 6K is an LCM. When I simplify here, I will have 3 and here I'll have 2. When I add them, so 1 over total is 5 over 6K. But I need K. If I need K, cross multiply. So that's why the K, the total is 6K over 5. Is it clear? Now, we need the extension, increase in length. So just recall the formula, that the Hooke's law, that F is equals to Kx or F is equals to Ke. F is of total force applied because we have a one spring which is having a constant of 6K over 5 and the one weight is W is applied, so force is W. The spring constant is 6K over 5 and extension is X. I need X. X is our subject. So it will be 5W divided by 6K is equals to X. So 5W divided by 6K is equals to X, or extension will be 5W divided by 6K. So A will be the right answer. Is it clear? Respond. So the important thing you remember when springs are connected in series, you add the reciprocal and take inward. When they're connected in parallel, just add the spring constant. Same like, why not 2W? Because the total force on this total force is W. The total force on the system, because what I did, I replace all these three springs by one. So when I replace all these three springs by one, and I worked out what is the spring constant of the system, the spring constant of a whole system was 6K by 5. So the force is W and the spring constant is 6K by 5. So just substitute the value F is equals to Kx, you will get the extension. X will change, but X is representing an extension. X will change, definitely X will change. For two springs, the value of X is different. For one spring, value of X will be different. For all parallel, value of the X will be different. But we just need the value of extension. That's why we work out X here. Like that is the extension of this whole system, not individual. We do not consider individual extension. We just work out the extension of whole system by replacing the whole system by a single spring. Like another example, if I say I was having springs in this manner. This is K, this is K, this is K. An example, this is 3K. And the weight W is attached. Now, what is the extension of this whole system? So first, what I will do, I will replace these parallel. How to replace these parallel by a 1? Because when they are connected in parallel, we just add. So this will be 3K. This 3K is in series with another 3K now. What is the spring constant of this system? So I will take an LCM. So 3K will be an LCM, so it will be 1 plus 1. So 1 over KT, the total. So it will be 3K divided by 2. That is the spring constant of the whole system. So means this whole system now is replaced by a single spring, which is having a constant of 3K by 2. And the weight W is attached. So what is the extension? So F is equals to Kx. This X is a extension of this whole system, not individual. So F is a weight here, and this will be 3K by 2. So when I simplify, it will be 2W divided by 3K. So that is a different type of question, but the same idea. Is it clear? How to work out the spring constant of the spring systems? If they're connected in parallel, add. If they're connected in series, then add the reciprocals, and at the last take inward. Instead of doing for individual. Question 21, what is represented by the shaded area? What is represented by the shaded area? It's area under the graph for a stress strain graph. So what actually it represented? It represented the energy density. Energy density means how much energy is there in a unit volume. So if it was a force in extension graph and we are taking the area, what the area under the graph represent? Area under the graph represent the energy. But when we have stress and strain graph, what area under the graph represent? It represent energy in a unit volume, or we also call energy density. So strain energy of a wire, no, it's not a force. This is strain energy over cross-sectional area. Why? How you get? Look, it will be half stress into strain. So it will be half stress into strain because it's a triangle. What is the stress? Stress is force over area. And what is strain? It is change in length over original length. So when I further simplify here, it will be half F delta L divided by AL. When I write the unit, what is the unit of the force? Newton. What is the unit of extension? Meter. What is the unit of area? Meter square. What is the unit of length? Meter. So when I simplify, Newton meter divided by meter cube. I can cancel this all as well, Newton divided by meter. But if I say Newton meter is joules and a meter cube is a volume, mean Newton meter is cell with a unit of energy and the meter cube is a unit of volume. So it's energy per unit volume, or we can say energy density. Half did not disappear, but I'm writing the unit because half does not have a unit. That's why I did not include that. Half I will use in a calculation, but 1 by 2 does not have any unit. I was writing the unit for each of them. That's why I did not include half. So D should be the right answer for this. Question 22, 23, any doubt? Yes, there's also another way of doing the same question as one of the student mentioned. She worked out the base unit, so that's right. So the one which give you the same base unit, that's also correct. But directly for such question, stress strain graph, the area under the graph give us the energy density. Any other doubt? The last questions. 25, the answer. For question 25, the answer is A. Micrometer is more accurate in measuring the length or the thickness. That's why. Like a student take measurement to determine the density in the form of a long wire. There's a long wire. So student need a density. Density is mass over volume. How will get the mass? By using a top pen balance. How to get the volume? Volume is area multiplied by length for a wire. To get the area, we need the diameter. And because for a wire diameter, it's small, so micrometer is more accurate. It can measure 0.01 millimeter as compared to a vernier caliper, which is 0.01 centimeter. So even though vernier caliper, micrometer, both can be used for the diameter, but for a diameter of wire, accurately as possible, micrometer is the most accurate as compared to a vernier caliper. Any other doubt from this pop quiz? Diameter is not area. From a diameter, we can work out the area because the cross-sectional area of a wire, we work out diameter, and diameter, half of a diameter will be the radius, and what is the cross-sectional area of a wire is pi r square. So it's not the diameter time length, it is area times length. And how to work out the area is pi r square, or area of cross section of a wire, you can use pi d square by 4. But for that, you need a diameter or the radius. So directly area cannot be measured. You have to work out either a diameter or radius to know the